Hello everyone, my name is Jingyu Zhang, and today I'd like to present you with my summer research. Our astrophysics summer research focuses on studying B-type supergiant stars. Supergiant stars are the most massive and luminous stars in the universe. Supergiant stars are powered by shell burning, which causes their strong stellar wind. And effective temperature is a key parameter to studying supergiant stars. As astronomers know, strong stellar wind can affect how well observations agree with the pre-existing atmospheric models. So our research question is that we want to know how well our current temperature models agree with the observed and derived temperature values. We hypothesize that due to the strong stellar wind factor for B-type supergiant stars, the two atmospheric models under-predicts their effective temperature and over-predict their angular size. The method we use is called spectrophotometry, which measures the amount of energy transmitted or reflected by the star as function of wavelength. We collected the data for UV, optical, and infrared spectra from the Astronomy Open Resource website, SIMBAD, and VZR. We also collected the stellar atmospheric parameters such as effective temperature, log G, reddening parameter, EB-V, and the star companions from peer-reviewed articles. And we worked on 20 target stars this summer and primarily used the interreactive data language IDL programming for data analysis. We created chi-square contour maps. The contour maps are the chi-squared of reddening as a function of angular size and effective temperature. Also, it is as a result of fitting model of spectral energy distribution plot. The red diamond in contour map indicates that the best fitting model temperature for our directly determined angular size. Then we have spectral energy distribution plot, SED plot, a graph of wavelength versus spectral fluxes. We obtain derived temperature from SED plots. As a result, we plotted two bar charts to compare the measured and the model angular size, also compare the literature temperature and the model temperature. The reason we only included 4 star samples is because by the time we did the research, there were only 4 observed angular size by Charra interferometer. In the future, we'll definitely include more samples. So figure 4 indicates that the model angular size is higher than the measured angular size. And figure 5 shows that derived temperature in general is higher than the model temperature. We also plotted a scatter plot of model temperature versus literature temperature with all 20 samples we have. As figure 6 shows, the points in the scatter plot is point to locate above the y equals x line, which suggests that the literature temperature is higher than the model temperature. From the calculation, we find that literature temperature is around 4% higher than the model temperature. So in general, current result matches our hypothesis that the atmospheric model underpredict the effective temperature and overpredict the size. So in the future, it may be necessary to employ the models that include the winds to match our temperature results. So thank you so much for listening to my speech.